All right, so this one is talking about swim time. We've seen swim times before. So the table lists the time in seconds that an average athlete takes to swim 100 meters freestyle at age X years. Find a model for the data, then calculate the age at which the minimum swim time occurs. Also calculate the minimum swim time. And then according to the table, what does the minimum swim time occur and what is the minimum swim time? Well, that one we can do with just looking at the table. So and the minimum swim time is 49 seconds. And so 49 seconds at age 24. So C is done. Now we just have to get our data, do some derivatives, and then we'll be done with that one as well. So I've plotted the course here, and that looks pretty quadratic. It looks like it's going to have open up. And so let's go over to 5. And we'll do 1, 1, 1. The vars will go to 1. And so this is going to be our equation. So let me write this down. And again, I'm going to write probably 2 4 decimal places, and that should be good. So now let's look and see what kind of curve it looks like. Yeah, that's not bad. All right, so let's start there, and we can then start taking derivatives. So A is the model. So that is maybe time and age. So T of A is equal to, now am I going to remember to put A in there? Probably not, but that's okay. 0.1811 A squared minus 8.4625 A, and then plus 147.37, I think it was 0.6. And this is going to be seconds for uh, age basically 8 to 32. Okay. So basically, based on X is going from 8 to 32. So that's going to be a range. So we'll have those for endpoints, and then we'll have some middle point in the middle somewhere. Okay. So now we need to calculate the age at which the minimum swim time occurs, also calculate the minimum swim time. So what we need to do is find T prime of A. So that's going to be 2 times that. So it's going to be a 0.3622x and then minus 8.4625. Okay, so that's pretty easy. Now we need to calculate when A is 0. So let's again, hey, let's use our calculator. We have a calculator, so let's do that. And so we want Z or 0 here, and then let's take the derivative, we'll say of y1. And so then we go over here, that looks good. So now we're taking and finding where that 0 is. So let's try 32, and we'll use the graph button instead. And so that says 23.3683, and that's going to be our value. What if we try something closer to the other end? We still get that. And if you think about that, that's going to give us a straight line through the graph, because it's going to be a linear model. So we're expecting just to have that one. So A equals 23.368275 that's going to be our age. And so that's in years. Now 0.368275, what does that equal? Well, let's see if we can come back over here, and we'll go 368275. We'll just go 368.275, and we'll figure out how many months it is, at least get to the months. So that's 4 months, 4 point, almost a half month. So we'll say that this is 23 years, 4 months. Okay, so that makes it a little better here as far as what we understand. All right, and what is the time at that point? Well, now what we have to do is we have to go back over to our graph, and we have to do a value. And so that was 23. Now we have to convert it back to decimal. We can't use the other value. And so that gives us 48.498, and that's going to be seconds. So we have T of 23.368275 is equal to 48.498 seconds. And so calculate the age at which the minimum swim time occurs and also the swim time. So approximately 23 years, 4 months, we get a minimum time of 48 point, let's call it 5 seconds. Okay. Now, that's pretty close to just coming off the table. We had 23.4 and 48.5. This is 24, it's just a little bit higher, and 49, just a little bit higher. And so, pretty close to the table values, but this is a little more exact because we used a full set of data to get it instead of just that one line. Okay. And so that's what I would do for that one. And that's all I have for you for this section.